In this short video, we'll be discussing some theory about how to organize OTLs for a setup. Different people take different approaches, so in this class, we'll look at two of the most common. The first is the one giant OTL approach. This means that we take our setup and build a single OTL out of it. Often people who take this approach will anticipate the way that users will run through the OTL's interface and create a left-to-right series of tabs, representing the steps the user needs to follow in order to get a result from the system, with geometry output on each tab to lock it off before moving to the next step. This has a few advantages. It's very simple to hand off if your pipeline department doesn't provide a system for handing off OTLs, since it's a single file you just give to your users. It's also very simple for users to understand at a glance. Often studios will hire minimum wage employees to run setups in shots, and this kind of setup with clear step 1, step 2 type direction can be easy for them to follow. The disadvantage to this approach is that inevitably people will unlock your OTL, and once that happens, they can't pick up any changes you need to make to it. It's possible for studios to forcibly prevent some users from unlocking OTLs, but to my knowledge, it's rare that they take this step because it limits flexibility. Sometimes people legitimately do need to unlock your OTL, and there isn't time under strict production deadlines for them to wait for you to add the feature they need. Why users unlock OTLs is kind of interesting to consider. It is partly because it's impossible for you to predict everything they might need to change in their shot, to be sure. But even if you could predict those things, most of the time people who like Houdini are tinkerers, and tinkerers like to feel like they are power users tailoring the setup to their particular needs. It's a rotten shame to tell bright people like this to quit unlocking your OTL and just dumbly press buttons. Our second approach attempts to provide an answer to this problem by limiting the damage users do by unlocking parts of the system. We do this by splitting our setup into logical steps and making each step into a separate OTL. You might think of this as taking the tabs from the previous approach and using OTLs instead. Then we use some technique like a self-extracting OTL or a shelf tool, which we'll be looking at later in this class, to organize the OTLs top to bottom, left to right, in order of the steps the user needs to take to create a result. This way, if the user wants to unlock something and change it, they are only unlocking that one step, and there's a chance you might be able to release changes to other parts of the setup still. This has the disadvantage of being confusing or complicated for some users, who seem to find the organization of the tabs more intuitive. It's also a bit unwieldy to manage if your studio doesn't provide a system for it, since instead of distributing one OTL file, you have to distribute several. I would say that neither way is objectively correct, though I personally tend to prefer the approach with multiple OTLs. And since it provides us with lots of opportunities for learning, it's this approach that we'll be taking in this class. Another thing to consider is whether your OTLs should live at SOP level or object level. In fact, OTLs can be created in any context, though object and SOP level OTLs are probably the most common, and are the two types of OTLs we'll be targeting in this class. Now, some people create entire setups at SOP level, which is, again, definitely not wrong. It feels right in many ways, since often a setup is about building a single geometry object. The disadvantage to this is that we are restricted to only geometry operations, meaning that if we want to use object-level transforms, we can't. Also, something we'll be looking at in more detail later in the class is how to give the user options regarding what's displayed on any given OTL without affecting the next step in the setup, which is more difficult to do at SOP level since SOP-based OTLs want to just output whatever is displayed, or whatever the output node is connected to. You can get around this somewhat by leveraging the difference between display flags and render flags, but in my opinion, the options available to us at object level are simpler and more powerful, since we can have multiple objects inside our OTL and strategically decide which of them have the display flag turned on. In this video, we talked a bit about the theory behind OTLs, and settled on one to use for our class. For the remainder of the class, we'll be looking at how to apply this theory to a real-world setup.